Okay, remember some of you are really running up against the buzzer when we do our quizzes, so get going. Quick, quick, fast, fast. It is not a group effort. I want to know what you know, not your neighbor knows. Getting the 4 or 5 here, not knowing what you're doing, doesn't matter because it'll show up on the quiz. Okay, with this and quiz today, remember, make sure you can see the features of the graph. If you have to alter your scale to see those features, you should do so. Okay, it doesn't have to be perfect. Remember we had one yesterday that was 3,000 something for a maximum. We were able to ballpark it as long as we labeled accordingly. How do I function without caffeine?
You just aren't in control.
Oh, let's go see about that way. Who's still rolling? Okay, one potato, two. Don't be bashful about saying I'm still going. I gotta know. Okay. Not asking for art. We're just asking that it makes sense, that it's proportional. You know, if you got a graph that looks like that, then don't draw that, right? Like, make sure it's proportional, it's relatively to scale, it's got its points labeled, the labels actually match the scale. We're going to see that a lot in chapter 4, where instead of trying to fit our graph to a certain scale, we're just going to say screw it and change our scale every time. Okay, makes life easier. Okay. So, leading term test. I have 2 x's, 3 x's, 4, 5, 6 x's, and it'll be negative. A negative 2 x to the 6 as a leading term. Tells me that I'm going to have end behavior of negative infinity, squiggles, negative infinity. Then, zeros. I have 0, and it's going to happen like a parabola because it occurs twice. I have 3, and it's going to happen like a line because it happens once. I have -2, it's going to happen like a cubic because it happens thrice. So label your zeros at 3, at -2, at 0. I just hear a squeaker. No? Oh, that'd be funny. It's just a matter of, I know it's going to come up and hit -2 like a cubic. It's going to hit 0 like a parabola. It's going to go through like a line. The question is just, how far are those going? So you head to your calculatron. You know what? I ain't going to go to my calculatron. You know how to go to your calculatron. Tell me, what are my relative and absolute maximums? So on the graph, not bad. And then 9.5. Okay. Confirm. Seeing lots of bobbleheads? Great. So I need to change my axis to match that, and I need to go up to at least 590. I don't know. It all depends, right? Because some of you just did this on regular line paper. Some of you have your own graph paper and just went really tall. I've got 10 boxes to work with. So me personally, I'm just going to go by 60, because then 10 is 600. Just go right below that. So at 2 point some stuff, I'm just below 10. And I have it written over here. That's okay. If you ever don't want to clutter up your graph and write it off to the side, that's fine. Maybe just say that's my absolute maximum. And then negative almost 1, 8 point something. So negative almost 1, 8 point something on a scale of 60 is barely off the line. So I will come up, cubic, hit the hump, parabola, into that. Okay, so what I meant about it being proportional, you can't just draw that and then put numbers next to it, okay? That's not graphing it, that's BSing it. You have to have something that was relatively proportional, where your first relative maximum is definitely lower, significantly lower than your absolute. Okay? So, and we need that little kink right there for our cubic. We should have, do you have your zeros? Do they have the correct behavior at each? Do you have your extrema labeled? Is your graph the correct proportions? Okay. There you go. Yeah. Did we? Oh, there is that relative minimum over at 0, 0. Yeah. I wasn't thinking of it because it's zeros and because last night sucked. It was so long. Yes. Relative minimum at 0, 0. Good call. Well then, let's say for having the correct, you know what, for having the correct extrema values for labeling them correctly. Like you have which one's relative and absolute, which one's minimum and maximum. Good call. I only talked to 7 people last night. It was dead. It was just boring. I was going cross-eyed. I was sitting here playing Viking Bubble Pop. Okay, so nothing. Okay, from the homework. Okay, I know we had one of the regression problems in there, and depending on your fluency with the calculator, maybe that took a little longer. But how'd we feel? I tried to balance it out. I remember there was one that was just look at it and say the thing. Okay. Yeah. 81. Okay. Hey. Come on. 81. Okay. For each of the following, determine the least possible degree, blah, 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 blah. Locate the zeros, multiplicity, create the function. Gotcha. All right, I'm not going to multiply it all out, but how we do it. What's the total degree on it? Odd or even? Okay. Same end behavior, so I know it's got to be even. It's got some mojo going on, so it definitely ain't squared. I got to at least start with to the fourth and higher. Then I look at the behavior through like a line. So I know that x plus 6 happens once. Bounces off. Would you say that's wider, parabolic, or is it more U-shaped, like it's to the fourth? Okay. Looks a little wider, right? Like it's got that curve outward instead of just straight down. So I'd say that this one is most likely, wait, it's all blurry there. Okay. I'd say x plus 2 squared, because it behaved like a parabola. And I don't see a kink to this one, so I'm assuming that it's x minus 4 to the first as well. Okay, I got that much. Positive x, positive x, positive x, positive x. That'll make it go upward. Good so far. The catch is, how do I include this point? It is a turning point. It is a maximum. But to make that specific point show up on there, throw a stretcher compression in there. And because it's a point, because it's a coordinate, it's an x and a y. Shove 2 in for x. Shove negative 128 in for y. Solve for a. You're good to go. Okay. A lot of our application problems will do that. In fact, I've saw that a couple of times on our ACT review as well, where they have this idea that you have to remember after all this formula stuff that you're working on, oh wait, I can just plug an x and a y in. I can just plug numbers in. Okay? So I'm going to start with, that's the behavior in the zeros. I just got to know what I'm multiplying it by to stretch it down. Okay? And I think there was one who asked that. Yep. Okay. 48. 48. Okay, according to the price model, during which year was the price 7 cents for the second time? Okay, so remember how, all right, our spaghetti monster from our last one yesterday. If they said, when is y this? We remember that that's go put y in, come on. Frank, you're holding up the show. Go put something in here and say, oh, 20. You graph it. Okay? And you make the intersection. Which model do I choose? Well, What I would look at that, remember the whole interpolation, extrapolation thing? I would say if it hit your line inside your data set, pick the one with the greatest R coefficient. If it doesn't hit the line inside your data set and hits it outside your data set, then I would pick the one that just makes the most sense. You have to choose the model that makes sense for the question they're asking.
Okay, so would C be inside the data set then?
Well, I don't know. I would have to see the graphs because
It's like between 2000 and 2005. Would that count?
yeah, if it hits those curves somewhere in here, that's inside your data set, I'd use the one with the highest coefficient.
Okay.
Yep.
The highest coefficient?
Yeah. The greatest percent fit, the 97 point whatever. Yeah. Yep. Yeah. But if it went past, let's say it didn't hit any of those curves until 2030. Well, now I'm going to choose the one that just made the most sense in the long run. Okay? Like that was the big thing. Most of it was calculator mojo. Remembering that from Algebra 2, the big thing that we had to remember was if it's inside, interpolation, best fit. Outside, extrapolation, choose the one that makes the least dumb. Makes least dumb, yes. The head cold that hit the whole house this week finally got me. Everything's like the. So, but test kits have rent paid in our nostrils and cranial cavities, so we know that it's not the bad. Anything besides those two? I mean, there were only, what, 5? So, okay. Then, if you want to scramble yourselves up an hour later, movement, I'm not doing it until you make me. All right. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 3, 4. 1, 2, 3, 4. All right. We have covered 1-7 inverses, 2-1 monomials, both in terms of graphs and analysis and radical equations. And then 2-2 was polynomial stuff, analyzing the graphs. So, only 3 sections, expect 2 each. First one, do you remember the trick to finding the inverse? Swap x and y. F of x gets me the rule, gets me the y, so I can replace this with the y, and then I'm going to swap those. X is y minus 3, y plus 2. I cross multiply or multiply both sides by y plus 2, whatever your jam is. When I do, I'm going to distribute. That's xy plus 2x is y minus 3. I want y by itself, so all the y stuff to one side, all the not y stuff to the other side. So xy minus y is negative 2x minus 3. I want y by itself. This was where, if we forgot the trick from way back in the day, we started being the Yorkie chasing the tail. What's the trick? Take y out. I factor it out. Because now it's y times stuff. So I can get y by itself by dividing by stuff. Getting inverse function of x is negative 2x minus 3 over x minus 1. It says find the inverse and its domain. So any restrictions to this I have to include. What does it say, and domain or restrictions to domain? Okay, so we're going to say it for real. Right now I'm just going to say x can't be 1. Up here, remember that the domain and range swap. If the original has a domain where x can't equal negative 2, range, this one might not be very fair because not everyone came straight out of Algebra 2. Do y'all remember the rules for where the horizontal asymptote is on these? Okay. When the degrees are the same, it's the leading coefficients. Y can't equal 1. There's going to be a horizontal asymptote at y equals 1. Well, then the degrees aren't the same. It's the coefficient. If it was x squared over x squared, I would take coefficient over coefficient. When it's x squared over x, that's a whole different beast. That gets oblique asymptotes. We'll talk about that in section 2.5. Okay. But you see again that when the domain and range swap, it says does not equal 1. So I'm just confirming that that was the only restriction. So I will say negative infinity to 1. Can't touch this. And 1 to infinity. There you go. Okay.
So you don't want restrictions, you want the actual domain.
That was a discussion we had. If it says find the domain, you write the domain. If it says the restrictions to the domain, that's when I can just say x doesn't equal 1. Okay. Because if I put 1 in, 1 minus 1 is 0, can't divide by 0. Okay. No guarantees that it's going to be a rational function there. It might be a parabola. It might be a radical. It might be any number of the things that we have because number 1 is going to be find the inverse and its domain. And everything that we talked about is fair game there. Number 2 will be something, word problem, what does inverse mean? So, a crack dealer, plumber, charges $50 for a service call and $40 per hour for labor. Write that as a function. $40 an hour plus $50 to show up. If any of you work with, have family who are, or have had to have a service call by any tech professional, plumbers, HVAC, electrician, this is cheap. That's real cheap. $65, $70, $80 an hour is probably more like it. It's pretty gross. Find the inverse, describe what it means in the context. So if I'm going to describe what the inverse stuff means, then maybe over here, I should write what this means right now. What is x in the context right now? Hours. What is f of x or y? The total. Money. We don't just want to say money because remember you can have money input and output. The cost, the bill, the price, something that denotes it's what you're going to have to pay out. Okay, I like cost. Okay, go and swap. X is 40y plus 50. I'm guessing because it's linear, most of us are okay with doing that mental math. Subtract 50, divide by 40. I'll subtract 50, then divide by 40. Okay. So, all right, I'll write the middle ground. I see scrunched foreheads. I'll write the middle ground. Right? Subtract 50 over, then divide by 40. Okay. Once I'm here, this is my inverse. Right next to it, I'm going to say, what does it mean? Well, now my input is the cost of the repair bill. My output is the hours they spent on the service call. It's that simple. Don't overthink it, but also don't get lazy on your wording. Like on these, I've had kids say time money. Close. Okay? Or they'll say charged price. Like, aren't those kind of the same thing? So just be a little careful with your wording. Remember, more words is always better. I've told you before, sometimes you can get credit on things by just over-explaining what your thinking is. Okay, graph and analyze. Tell me all the stuff. Domain, range, x-intercept, y-intercept, continuity, symmetry. That doesn't even ask for symmetry. I don't care, I'm writing it. Increase, decrease, limit as x approaches. Okay, I'm going to write all the stuff. Do you know what this graph looks like? What? It does have an cube steps twice as fast. So poke, poke, and it happens super sharp. Like if you go and look at the graph on your calculator, it is just smacked up against those axes. It happens very sharply because it's x cubed, and exponents have a lot of power to them. Nothing? No? All right. Domain. Everything but 0. Same thing for range. So for both of these, I'm going to say it is negative infinity to 0, can't touch a span, and 0 to infinity. X and Y intercepts. No. Continuity. Okay. If it's continuous, you say continuous at where? If it's not continuous, you say what type of discontinuity and where? So this one has what kind? Infinite. Oh, no, no, no. We don't have, it doesn't jump between rules. It does jump from one part of the graph to the other, but it does it at an asymptote. So it's infinite. The only time I can have jump discontinuity is when there's a piecewise defined function. I have infinite discontinuity at x is 0. Symmetry, I know it didn't ask for it, but do you remember what it is? Origin. Okay. Symmetric to the x-axis can flop down or up. Symmetric to the y-axis can flop left to right like a book. Symmetric to the origin, I can turn my paper 180 and it's the same graph. Okay. Intervals increase and decrease. Remember, left to right across the paper. What is my y doing? The entire time, just that little gap at 0. So we're going to have nothing here, and here it's a repeat of my domain. Negative infinity to 0, 0 to infinity. Limits as I approach both negative infinity and positive infinity. If I were to plug this in my calculator and spam 9s, going all the way out to infinity and beyond, gets real close to what? 0. Okay, the handful of parents that I did talk to, I show them your review and the quiz side by side. And I swear they look over at the kid and just drill laser beam holes through their head. Okay, you get to tell yourself how to do this. How many of you have come back to look at one of your old quizzes? I'm still waiting on the last few to finish so I can hand those back. How many of you have seen your old quizzes and it was literally just, I didn't do that? Okay? Maybe a note to yourself on the review. Make sure you do all of these. Like, check them off in the verbiage as you do them so you know you did it. Okay? I used to cross out instructions in problems as I did them, so I know I did the whole problem. Okay, then we did radical equations. You know I'm going to put the uglier ones on there. Okay, this is the one that we had trouble with because we kept squaring like freshmen. Don't square like freshmen. Step 1, square both sides. Getting x minus 10 is square the first term, square the second term, multiply and double, because I'm going to have 2 of those terms. You've had someone trying to teach you that trick since Algebra 1, but you just said, oh, I'll just FOIL. Well, if you don't know the trick, then FOIL. Write it out, right? 4 minus bleh times 4 minus bleh, and get your arrow on. Okay? Now that I have squared it, I need to isolate that next radical. 16 minus 24 is negative 8. I'll add 8 to the other side. Subtract 2x to the other side. Radical stays. Square both sides. Don't square like a freshman. When I square this, square the first term, square the second term, multiply positive 2x, and double. When I square a radical that has a coefficient, you square outside, then square inside. Squaring outside is 64. Squaring inside is 2x minus 24. Disturbert? Get 128x, minus 64, 256 by 6, 1200, 300, 1500, 1536. Okay. Then it's a quadratic. Everyone to one side of the bus. Subtract 128x. Add 1536. I bet it's factorable, but boy, do I not want to do factors of 1540. was that? 20 and... Oh, Jesus. I'm so tired. All right. If you don't want to factor, what do you do? Complete the square quadratic formula. Whatever your jam is. I know it's factorable. I know it is. Ah. $124. So I know it's divisible by 4. So 4 is 432. Ain't it? Oh God, it's negative. That's why. All right. There's a magical button on these 36s that I love. It's the prime factorization button. So 1, 15, 40, math 4, poke. 4, 5, 7, and 11. Okay. So 4, 5, 20, 20 and 77, no. 24, 44 and 35, no. Oh, you got to split the two. Okay. 14 and 110. I'll just save you some time there. Okay. So I know it's factorable. Just okay. The catch with it was when I had 14 and 110. I have an even radical in my original equation. I have to make sure that I check my answers. So, shove 14 in there. 14 minus 10 is 4, square root of 4 is 2. 14 by 2 is 28. 28 minus 24 is 4. Square root of 4 is 2. 4 minus 2, yes, is 2. Checks out. Throw in 110. Get square root of 100 is 10. 220 minus 24 is 196. Square root of 196 is 14. 4 minus 14 is a negative 10. Okay. Since 10 does not equal negative 10, when I plug this in, I have to cancel it. Okay. Sorry about the big numbers there. Somehow I don't believe the teenager. Okay. And then, section 2.2, find the number of possible zeros and turning points. How? Y'all, how many times did I forget that line just in our notes? And then just went straight to the factoring. Don't miss that part. Okay? Don't get the 1 or 2 points off for just, oops, I didn't read all the directions. Okay? I'm guilty of it too. Factoring. First stop on the factor train is always what? Take that GCF out. X to the fourth minus 10x squared minus 24. It looks like a duck, it quacks like a duck. Turns out it's just a really sick goose. I can factor it either with the U method, or if you're okay with just doing it with x squared there. Depends on your jam. Factors of negative 24 that add up to negative 10. Hmm? See, this is one of those dangerous ones again, right? Because 6 and 4 add up to 10. But it has to be a negative 24 and a negative 10. Yep. I'm just checking. Just checking. Okay. From there, you have the choice of either continue factoring by difference of squares, square root of 12, make sure you simplify it. 4 times 3, square root of 4 is 2. So I'd say x minus 2 root of 3, x plus 2 root of 3. Sum of squares. Same thing, but with an I. X minus I root of 2, x plus I root of 2. Or, now that I'm in that factored form, I can set each of them equal to 0. I could also take him, say x squared minus 12 is 0, x squared is 12, x is plus or minus 2 root of 3. Okay? Yes. I'll tell you the directions are always the same. Okay? If it says factor completely, you have to go to yellow. This one does not, and it will not on your test. The directions are always the same. I change up the problem. Okay? The next quiz we take, after we do more stuff with polynomial zeros, that one you're going to have to go to linear factorization. Okay? And this, I could just, whoop, x squared plus 2 is 0, x squared is negative 2, x is plus or minus I root of 2. I can do it that way as well. Okay? And then the last one, exactly what we just finished doing. Apply the leading term test for end behavior. It doesn't say state the end behavior. You don't have to write it as limits. But I can look at this and say 3x's, 4x's, 5x, 6x's. This is going to have a positive x to the 6th. I know I have positive infinity both ways. Okay? That's what it means by apply the leading term test. You don't have to write out the limits. That's fine. This is just so I know what my graph looks like. Then, zeros. I know 0 happens thrice, so it's going to look like a cubic. I know 3 happens twice, so it's going to happen like a parabola. And negative 2 happens once, so it's going to look like a line. So, negative 2, 0, 3. I know this thing will come down from infinity through negative 2 like a line. It's going to go up through 0 like a cubic. It's going to bounce off of 3 like a parabola and head back to infinity. The question is, how low do you go? And I may have to change the scale of my graph to match those. So someone go find our minimum, someone go find our maximum. Oh no, this one's going to be absolute minimum. Okay. Absolute minimum. How low did it go?
1.57.
7.5?
34.
What?
34.
Oh. Literally feels like I just came out of the pool. My relative maximum. How high does it go?
1.96. 32.36.
And oh, I just wrote that in the wrong spot. Never mind. Whoop, whoop. I also have a relative minimum in there because I didn't want to get got.
Is that on the last diagonal?
Right? That is a relative minimum. It's also a 0, but it is a relative minimum at 3, 0. So I would need to change my scale to go probably by, I'm going to be lazy and go by 3 and just go a little off-road. Negative 1.57, negative 30, 4-ish. Absolute minimum. I'm going to go to almost 2, 30, 2 and change. And that's my relative maximum. And then I'll connect the dots. Making sure to put that kink. Oh wait, no, it kept going. Crud. There we go. That's a horrible graph, but I would take it on a test because all your points are there and labeled in the right spot. Okay? Devices to the counter. Scramble yourselves up. Don't sit at any table next to the person you would normally sit next to, or that you know I would have a problem with.